Hari Om. Already we have discussed mean in two methods, that is direct method, assumer mean method. Again, to recall that, once again I am explaining this formula that it is in direct method, it is sigma fi xi by sigma fi, that is fi is frequencies, xi's are observations. Coming to when these values are numerically large, then we are going to discuss about the we discussed about the assumed mean method, that it is a plus sigma fi di by sigma fi. Here from these exercise we have taken one assumed value, that it is a. Now the deviations are di is equal to xi minus a, where this a is assumed mean from the exercise. Coming to the next one, that it is step deviation method. Again, why we are taking this step deviation method means, if the values are smaller numerically, then we discussed in this. If fi's or xi's numerically larger, we have taken this. And the third one also, when the values are larger numerically, and the second case also, wherever the class interval is not same throughout the table, in such a situations, in such a cases, we use this step deviation method. So in the step deviation method also everything is same, that it is x bar is equal to a plus sigma fi ui by sigma fi into h, where this a is assumed mean and h be the class interval. Coming to that, coming to this ui, here ui meaning is di by, either we can take a common divisor in that column, or else length of class interval. Why we are taking this means, again to reduce these ui values larger to smaller. So this method is useful in two cases, wherever the di values are larger numerically, and the second case is length of class interval is not same throughout the table. In that case also we can use this step deviation method. Coming to this step deviation method, let me to take one example from our textbook. Example 3. Here in this example 3, the distribution below shows the number of wickets taken by bowlers in one-day cricket matches. Find the mean number of wickets by choosing a suitable method. What does the mean signify? Here the suitable method is step deviation method. Why? Because one is here, see this class interval, length of class size 20 to 40. Here this is 40. 20 to 60, it is 40. 60 to 100, here length of class size is 40, but here 50, here 100, here 100. So the class length of class sizes are varying from here it is 40, 50, 100. So that the exact suitable method is step deviation method only. For this step deviation method also same as it is before, as we discussed in assumed mean method, how we changed these class intervals into classes into class marks, and the next fi's, up to that finding di, up to that it is same, and the next column will change with the ui's. Here see, once again I am recalling you that how to find out the class mark for each class. It is upper limit plus lower limit by 2. So 20 plus 60 by 2. 100 plus 60 by 2. Likewise 150 plus 100 by 2. So the remaining exercise are 125, 200, 300, 400. Now we are going to form its table. In this example, number of wickets 20 to 60, 60 to 100, 100 to 150, 150 to 250. So the class interval is not same throughout this data. So we go for the step deviation method. In this FIs are 7, 5, 16, 12, 2, 3 and sigma FI is 45. X already I discussed with you how to calculate X. So these are the Xi values. In that Xi values we should assume one value as assumed mean, that it is here I have taken that A as 200. You can try with any other these numbers, then also you will get same result. Now coming to DI. DI is Xi minus A. Xi minus A, 40 minus 200, it is minus 160. 80 minus 200, minus 120. 125 minus 200, minus 75. 200 minus 200, 0. 300 minus 200, 300 minus 200, 100. 400 minus 200, 200. These are the DI, deviations. Next, UI. While calculating UI, here the divisor we can take as its class interval if it is same, or else once observe these DIs, almost all the values are divisor of 20, so that here the DIs are divided by 20, so that minus 160 by 20 is minus 80, minus 8, minus 120 by 20 is minus 6, minus 75 by 20 minus 3.75. Likewise UIs are calculated. Next, coming to the last column of this table, FI UI. FI 7 UI minus 8 is equal to minus 56. 5 into minus 6 is equal to minus 30. 16 into minus 3.75 is minus 60. 12 into 0, 0. So now sigma FI UI is minus 106. Now put all these in our substitute all these values in formulae, that in step deviation method. Mean is equal to A plus sigma FI UI by sigma FI into H. Here what is our assumed mean? It is 200 plus sigma FI UI is 106 by sigma FI is 45 into H. Here I have taken this H as 20. Why? Because this entire DIs are divided with 20. So that I have considered that the class interval as 20. Now 200 plus minus 106 by 45 into 20 by dividing and by multiplying with this number we will get minus 47.111, and that it is 200 minus 47.11, it is 152.89. This is the mean of the given data. And here one more question they have given, that it is signify the mean of this data. Here about this we conclude this data is on an average number of wickets taken by these 45 bowlers in one day cricket is 152.89. This is the conclusion of this data. Next, coming to the exercise. In our exercise, one more important model, that it is already I discussed with you about exclusive classes and inclusive classes. Up to now, wherever we discussed the problems, all are, see that upper limit is equal to the next class of the lower. Up to now what we discussed, the classes, all the time we explained these classes with exclusive classes. But in exercise, first exercise, in the fifth problem, they have given that inclusive classes. How to change that inclusive classes into exclusive classes. Already in the before itself, while we are discussing that exclusive classes and inclusive classes, I have given a clear explanation about that too. And here I am going to explain you how to change this inclusive classes into exclusive classes. See that here the upper limit of a class is 52. Coming to that next class, its lower limit should be equal, then we call it as a exclusive, but here it is 53. Here it is 55, it is 56, 58, 59. So it is not equal. We should make it equal, so that we make this entire data into exclusive classes. So that, see the difference between these two, 53 minus 52 is 1, 56 minus 55 is 1. So all the time the difference is 1. So that here that 1 we can divide with 2, that it is by taking to change these classes, we have to add this 0.5 to the upper limit and subtract 0.5 to the lower limit. By subtracting this 0.5 from this 50, you will get 49.5. 52 plus 0.5, it is 52.5. So 53 minus 0.5, 52.5. 55 plus 0.5, 55.5. So here this inclusive classes is changed into exclusive classes. Now the remaining everything is same. Exercise 50 plus 52 by 2, exercise are same. Coming to DI, here I assumed mean as 57, so that these values, 51 minus 57, it is minus 6, 54 minus 57 minus 3, 57 minus 57 0, 60 minus 57 3, 63 minus 57 6. Again here in this step deviation method, again I am going to condense these DA values. One thing you can observe here, these all are multiples of 3. So that I am dividing these values by 3, then it is minus 6 by 3, it is minus 2, minus 3 by 3, minus 1, 0 by 3, 0, like that. Now coming to FIUI. 15 into minus 2, it is minus 30. 110 into minus 1, minus 110. 135 into 0, 0. 115 into 1, 115. 25 into 2, 50. So sum of FIUIs are, sigma FIUI is 25. Coming to formula, x bar, that is mean of this data, is equal to A plus sigma FIUI by sigma FI into H. Assumed mean is 57 plus FIUI is 25 by 400 into 3. Now it is this entire value 0.1875, 57.19. So up to now mean is discussed with in 3 methods. One is direct method, next one is assumed mean method, and the third one is step deviation method. This is about mean. Next coming to mode. Already we discussed about mode in a only for ungrouped data, that it is in an ungrouped data the most occurring, whatever the value occurs frequently is called its mode. Now in this next for grouped data also, by using formula we are going to calculate mode. Next topic is mode. Mode of an ungrouped data. See, first mode definition is most frequently occurred observation. Here I have some wickets by some bowlers, that it is 10 bowlers, 2, 6, 4, 5, 0, 2, 1, 3, 2, 3. Here what is the most frequently occurred number is 2. So the mode of this data is 2. If there are 11 bowlers and one more observation I added here as 3. Now here the most frequently occurred observations are 2 as well as 3 also. So for this data we have multimodal, that it is for this data 2 and 3 both are the mode of this data. So we call it as a multimodal. Here we have only 2, so 2 observations are frequently occur, so that bimodal also we can call. So this is about ungrouped data. Now coming to grouped data. Mode of a grouped data is, mode is equal to L plus F1 minus F0 by 2 F1 minus F0 minus F2 into H. Here just a little example, that it is we have the classes as 0 to 5, 5 to 10, 10 to 5, 15, 15 to 20, 20 to 25. Here the frequencies are 2, 3, 5, 4, 1. Here the model class of this data becomes F1 and its preceding model class is F0 and its succeeding model class is F2. Next, lower limit of the model class. In this data, this is L and H be the class interval, as you know. Here the class interval is 5 minus 0, 5, 10 minus 5, 5, 15 minus 10, 10. Particularly while doing mode, while calculating mode, the class interval should be same throughout the data. Then only it is possible to calculate mode of a grouped data. This is about mode. Next we discuss problems in the exercise. Second exercise, first problem we are going to discuss. In this exercise, the first problem is the following table shows the age of the patients admitted in a hospital during a year. The data is as follows. And in this question, they asked that interpret the data by finding its mean and mode. That is the question. Here in assumed mean method, we can calculate its mean, and mean of this data is 35.38 years. Meaning this mean represents that an average of patient, the age of patient admitted to hospital was 35.3 years. Next, coming to, so that this age falls, this 35.38 years falls at the age group of 35 to 45. So mode of this data becomes 23. Now model of this class becomes 23. Its preceding class becomes F0. That is F0 more its preceding class is F0 is equal to 21 and its succeeding class is 14. That is F2 is 14. Now mode of formula for mode is L plus F1 minus F0 by 2 F1 minus F0 minus F2 into H. As you know that this H is interval of this class. See that the interval is throughout the table is same, that it is H is 10, 15 minus 5, 25 minus 10. So H is 10. So that only I asked you to find its mean in assumed mean method. If the class intervals are not equal throughout the table, then we can go for the deviation method. Now coming to, by substituting all these values, and one more thing, this model class lower limit is 35, so that L is 35 plus 23 minus 21 by 2 into 23 minus 21 minus 14 into class interval H. Now 35 plus 2 by 46 minus 35 into 10, and by simplification we get its value as 1.81, and finally mode of this data is 36.8. Next, interpretation of this mode. Here the mode of this data is 36.8, meaning it represents the age of maximum number of patients admitted in hospital was 36.8 years. That is the mode. So up to now we discussed mean, mode. These two concepts were over. So these are the concepts about mode. For already ungrouped data we discussed. For grouped data, this is the formula and simplification. Hari Om.